Hey everyone, it's Mrs. Lawson. Here is the video review for the Chapter 5 quiz. So the idea of the first four is I want you to try to graph these without the use of your graphing calculator and to get as many points as you can possibly get, again, without the use of your graphing calculator. So as I explained in class, these questions are guiding you to understanding how to get the shape. So the first thing I want you to decide is it growth or decay? And on my first question, I can see that this is growth. And the reason why I know it's growth is because my B value, which is the base value right in front of the X, is bigger than 1. So I know it's growth. My shape is going to look like this. And then I can start to pick some points. So remember, the point you can always figure out is the y-intercept, because anything, make a little table here, to a 0 power, so 4 to the 0 power would give me 1. So I've got 1 point, I've got my y-intercept, and then I got a couple of options. The next thing I could do is just put 1 in there, and 4 to the first power is 4. I could put 2 in there, and 4 to the second power is 16. The other thing I could do is, if I read it like this, I can see my y-intercept, and I can see the growth factor, which means I'm always multiplying by 4. So times 4 times 4. So I can get 1 4 on here. I could even get 2 16 if I really estimated, but I don't need a lot of points. I just want you to realize again that you've got your wall, your asymptote of y equals 0, and that since this is growth, I should have a shape like this. So on my next one, again, the same idea. I know this is decay because my B value is less than 1. So decay is going to look like this. And I can also see my y-intercept. So if I just make a little table over here, and I put 0 in, again, anything including this fraction to a 0 power would be 1. And if I take that 1 times 10, I get 10. And some of you will recognize that that is just the y-intercept. And then I can get some additional points by using this growth factor. So just start multiplying by half. So half of 10 is 5, half of 5 is 2.5. So I can put my point, here's my y-intercept, here's 1, 5. I could even put 2, 2.5. And then don't forget my asymptote. Not that you have to draw in the asymptote, you just got to make sure it doesn't cross or touch the asymptote. So something like this. With this one, I am asking you to mention the domain and the range and the end behavior. So let's walk through that one. All right, so I do want to mark my arrows. So on this arrow, it's going to the left, and it's going up, and nothing is stopping it. And on this arrow, it's going to the right, and it is going down, but eventually it's going to get stopped by my wall of 0. So as far as my domain goes, again, I could write this, and I could put those infinities in there. Or if you prefer, you can just write all real numbers. Now for my range, it's not all real numbers because the smallest y value I wrote was 0, and then it goes to infinity. And remember, we never underline with infinity, and I won't underline with 0 because it's never going to become 0. It's going to get close to it, but once I underline that, I'm allowing that to happen. And I just realized I wrote this as an inequality. We would actually write it this, sorry. I'm in Algebra 1 mode right now, and this one I would write like this, so excuse me on that one. So not this. All right, my end behavior. So my end behavior, you're going to have to remember, you got to write all this stuff out. It's been a while. So when I write the one for infinity, x is going to infinity, but what I'm going to put is that it's going to 0. And this time, instead of an equal sign, I'm going to put an arrow because it's not actually going to get to 0. It's never going to equal 0. It's going to get close to 0. So we want to start making this transition over that sometimes we'll put an arrow here, which means it's going to get close to 0, but not equal 0. And then I can do this again for my negative infinity. And when x is getting smaller, f of x, you can put an equal. If you like this new option of an arrow, you can also put an arrow. But as x goes to a negative infinity, which I wrote here, I get my infinity. Okay? All right, next one. So on this problem, let me move my cord out of the way here. So on this one, again, what I want to do is make a table. And sorry, I'm having lots of chords here. And so again, E is a number. It's about 3. So with this being 3 as being the base, it is going to be growth. The y-intercept, again, I could just make a little table if I want. You don't have to make the table. But again, I want to pick 0 because anything including E or this 2.7 number, anything to a 0 power is going to be 1. And then 1 times 3 is 3. And again, some of you might recognize that that is the y-intercept. And let's say you want to try for another point. So again, this is about 3. E to the first is about 3 because anything to the first power is itself. So it's about 3 times 3. So it's about 9, not quite 9, but close to 9. So I could kind of maybe estimate that point if I want. And then with that, what I can do is now, again, I got my wall. It won't cross the wall. And I know the growth shape. So just something like this. Regardless on any of them, you know, how many points you're going to put, I at least need the y-intercept. And if you know the shape, that's going to be a pretty good graph for now. Later in the chapter, we'll get definitely more in depth with our graphs. All right, and then this one we did in class. So this one, the base looks like it's E, but we did discuss that that negative exponent actually means that it's 1 over E, which is about 1/3 to the x power, which since this is in between 0 and 1, you're going to have decay. And again, if you want to get your points, well, no, not if want, but you will. Again, get your y-intercept, anything, whether you look at it as E to the 0 power, 1 over E to the 0 power, 1/3 to the 0 power, you'll always get 1. Some of you might want to try for more points, so I could put 1 in there. And again, just 1/3 to the first power is 1/3. It's not quite 1/3, it's a little bit more, so I could estimate, go over 1 up 1/3. In one class, they suggested -1 because they remember if they put a -1 in here, then this would flip back and it would be